welcome to the May 2025 edition of PDH Hour with Glenn. I'm your host, Glenn Tepfer, and this week, this month, really going to talk about 40 years of geosynthetics, 35 years of work, some of the best unwritten guidance in the industry, really starting with the time frame of RCRA, and moving forward. I started in the industry in 1990, and really some of the best practices are things that, some of them seem to be forgotten over time throughout my career. So some of these might be a refresher from some of you that have been in the industry a while. I'm going to really cover things probably from anybody in the industry, manufacturers, regulators, engineers, designers, certifying engineers, installers. I think there will be a little bit of something for everybody in there. Basically, I'm going to start out, share with you, I think we're still an evolving industry. Then I'm going to look at things from an owner perspective, some of the things the owner can do, best practices to help keep their projects, get the best quality, move into the construction documents, pre-construction meeting, then spend a little bit of time on a few earthwork things. The bulk of the presentation will be on geosynthetics, mostly on the geomembrane, and then a little bit on textiles, nets, composites, and a little bit on final cover. Then I'll talk to you about the next webinar coming up in June, and should have time for some questions and answers at the end if I don't go down any rabbit holes here. Please feel free to use the question and answer button on your browser, and I will try and answer those at the end. Just as a reminder, before we get started, we have our prior webinars on the CQA Solutions website, but we can only issue PDH hours during the live broadcast, which is this, for those who complete the live webinar. So as I mentioned in the outline, an evolving industry, I really like to preface a lot of my training events with this now because, people are looking, some of these things may seem critical, but we're really an evolving industry. We're still learning, so they're not really meant to be critical in most instances. They're just really reminders that we still are evolving. We're learning as we go. Like I said, really the HDP geomembrane industry took off with RCRA in the 1980s. This photograph on the left, you can see, a lot of people, from the time frame when I started in my career, safety-wise, hard hats weren't required. You could wear tennis shoes on the geomembrane. You were expected to wear tennis shoes on the geomembrane. In fact, I early in my career was instructed to circle where people walked with hard-soled boots. Now that a practice wouldn't be accepted, we have to wear safety boots. But just we're an evolving industry, is my point. You can see more of a modern photo. 2008, everybody's got hard hats on. Basically, I tried to find a picture. I couldn't find any from the 1980s, but this is closest I could find as a resource. Fusion welders, thermal fusion welders, they were big, bulky. They often took two people to carry them, especially up and down slopes. They were hard to maneuver, especially trying to get through wrinkles and around wrinkles, obstacles, things like that. Definitely much bulkier today. They're a lot lighter. I think the temperature, unfortunately, has been increased on the welders, which might be leading to some problems. But these are a lot easier to move and maneuver, and one person can carry them and perform the function of the welding. When I first started, welding rod was coming into existence. Before that, you had canisters and you fed the extrusion welding beads in there, and those then were somewhat of a they still produced good welds, but they were also a safety hazard because those things got spilled on the geomembrane all over the place, and they became quite slippery when it rained or they got dust on them. Unfortunately, this is a modern version that we could find online. I couldn't find any of the photos of the old style canisters. These are the extrusion. They're a lot lighter than, the ones that were out when I first came in the industry, especially the canister ones. As I said, evolution, we had the resin beads that were poured into a canister and ground and molten and came out the extruder. Then we went to hollow welding rod, which was pretty problematic in and of itself. Better than the beads, I think, as far as quality went, but both had issues with moisture and dirt, especially the hollow, with getting hot condensate in there if you had differences in temperatures. So the solid welding rod is what we now predominantly use, and I think that produces a much more reliable weld. But again, those are just meant to be examples, that we're an evolving industry, and we're going to continue to evolve. So moving on to the owner at this point, many of you that have seen my presentations before, I presented this pyramid of what I call pyramid of success. You start with the owner involvement, then you have the vendor selection, your design and materials, or your design and specifications, your materials and equipment, and finally your field work. But I transposed this image this time for owners because sometimes everything's stacked against your success. You need to have the proper vendor selection, people that are educated, people that know what they're doing, proper materials in the design, proper equipment in the field, and ultimately proper and educated people doing your field CQA, your installations. And one thing that's important to remember is that, even regulators who are approving this, the education level and knowledge varies in the industry significantly. You can have good regulators, that are on top of it. You're getting things approved, might have a higher confidence level, but you could have regulators that are new. They're approving this stuff. They may have no idea what's good and bad. They may not do reviews. In some states, reviews aren't done by regulators, which is hard to believe, but that's the case. And as an owner, ultimately, you're liable, no matter who's at fault if there's an issue in the future. So as an owner, some of the things we recommend are setting goals beyond just the budgets and deadlines. What are your long-term quality goals? There should be goals as the project's constructed. Failure rates of destruct's one that comes to mind, something that you can have a tangible result on. Vetting your vendors, make sure they have experience on similar projects, and then holding vendors accountable. And being, that's done through daily involvement on the project. As an owner, if you're not out there keeping people held accountable, things can go awry pretty quickly, unfortunately. And then that leads to construction documents, which I think are really, next to the design, the biggest hurdle that we have, challenge that we have. And we always recommend constructability reviews because things in the field, if it's not constructible in the field, unfortunately, you end up with a field fit, and those field fits a lot of times are going to be inferior in quality than if it was properly designed. You're fitting something, you probably have poor welds, poor quality. If you can get it properly designed, the odds of improved quality are much better. The construction documents should be cohesive. Another reason for constructability reviews, there's in this case here, I gave different examples of the different components cross-referenced with each other. The middle one, technical specs conflict with a CQA plan. You have one per 250 yards versus one per 175 cubic yards. Those things should all be ironed out before the project ever starts, or you'll run into issues. And you also run into issues if you have regulators looking at them, looking at your sampling frequencies and saying, okay, you didn't follow the CQA plan, why not? Or you didn't follow the tech spec, which was more stringent, why not? And they can cause delays in your certification. The construction document should also empower the certifying engineer and CQA team. Best practice, if you want it done, put it in the construction documents, in the tech spec, CQA plan, wherever. If it's not in there, don't expect it to be done. And, there's a lot of things that we see in the industry that aren't done because it's not in the specifications, and engineers claim they have no foundation to stand on. I don't necessarily agree with that practice, but it is what's the regulator going to be looking at. And if it's not in the document, they can't enforce it. One of those things is, most specifications you'll see low ground pressure is approved, equipment's approved to work over top of the geomembrane, 5 psi, 6 psi, whatever it might be, pounds per square inch. But people will just push it over large wrinkles. So drive over wrinkles. In this case, it was an ATV that met the specifications of 5 psi or less. They drove over wrinkles all over the place. You've got hundreds, thousands of these creases in the HDP geomembrane. Creases are bad. They should be repaired. But again, it wasn't in the specifications. And then also not in the specifications was that these type of damages needed to be repaired. So the engineer leaves it. So now the bottom of your cell is littered with all these extra creases. Same thing with generators. We've seen creases caused by generators, especially the heavier generators with the hard rubber tires. And mechanical attachments and appurtenances, anything in the design, this is why we really stress the constructability review, trying to get these best practices implemented. And here, I gave this example in prior webinars, but you had an engineer that didn't know anything about the line or installation process. You had a contractor that didn't know. So they ended up, what they said, quote, nailing the crap out of the geomembrane to the forms. And so we ended up with hundreds of holes that shouldn't have been there in the first place. And, same project had some issues with the corners and their design. They had welds that were supposed to be done right in the corner. Anybody that knows extrusion welding, you can't weld right in the corner, even if you can with these specialized nozzles that people have come out with. You can't get a good grind in those corners. There needs to be a good abrasion and proper uniform abrasion. So the best thing to do is use prefabricated corners, get those welds out and away from the corners so they can be properly welded, properly tested non-destructively. Just increases your chance of having better quality. Moving on to the pre-construction meeting. A lot of times you'll see that, excuse me, parties, if the pre-construction meeting, people don't even do them. And I've talked about that a lot in training and maybe past webinars. But, the party should be there. CQA, this is a photo here. Installers QC should be there. We're driving up to the pre-construction meeting. The QC is helping do sandbags, and they're not out there as part of the meeting. Often it seems like things that may be said to the foreman don't get translated back to the QC, unfortunately, and it leads to the potential for problems on the project that aren't caught that should be mitigated. Same thing with reviewing all the documents at the pre-construction meeting. Someone should come there as a best practice with a specification summary, reviewing your CQA plan, your construction, tech specs, your CQA plan, and the drawings. And somebody should come there with a comprehensive list of requirements and make sure everybody's on the same page. We see where it's not done quite often. And GRI GM9 is a good example of that. It's a cold weather seaming plan, and everybody will have it written into their, CQA plan tech specs. If the ambient temperature drops below 40 degrees or 32 degrees, whatever the cutoff is going to be on the site, they're going to use GRI GM9. Well, the temperature drops below that, and everybody's scrambling to implement it. And there's things in there that need to be approved by the engineer beforehand, and they're not approved, and now the project comes to a delay. And that can be a costly delay when you're trying to beat the weather, especially if you're dealing with cold weather and snow regions. Safety, that's a big topic that should be discussed in pre-construction meetings, but often it's not. This is an example of a triangle of death where you have a pulley system being used to pull a roll of liner, cable pulling with another piece of equipment pulling it through the pulley. And the triangle of death is anywhere that pulley can break off and, kill somebody, either the cable or the pulley. In this case, pulley broke off and shot right through a porta-john that one of our technicians was going to actually use. And he realized it was in the triangle of death, and he went to a different one. This porta-john should have never been in the triangle of death. It should have been outside of that. Just improper practices all the way that actually could have killed one of our employees that actually is a Marine. They say once you're a Marine, you're always a Marine. So he is a Marine, and he served overseas in the Middle East, and to come back and almost be taken out by something like this would have been really tragic. I mean, really tragic no matter who you are. But more things on the pre-construction meeting, requiring supplemental or emergency work plans. I already talked about cold weather. There's hot weather. What do you do with hot weather? You should have limitations on your crews and exposure to the heat. Blackout mode's a big one. Night work's a big one. What happens if there's a rain event coming? Everybody wants to black out. If you don't have a plan, you end up with quality issues. Early in my career, there was we worked till 2 a.m. trying to beat the rain on a project, and the crew started up at the high end. I said, why don't we start with a sump? They said, now we're going to work towards the sump. It didn't make sense to me, but I was new in my career, and they get to 2 a.m, they shut off. They don't want to weld around the sump because they're too tired now. And so they left it open, come out the next morning, 4 hours later after it had rained, and it was flooded. We lost a GCL below, had to cut it open, had to repair it. In that case, might not be the worst thing that happened because those guys were already too tired. So they probably would have had poor quality welds anyway, but they should have started there while they were fresh. But things like that happen. That's why you need a plan. Same thing with material deployment. This is often overlooked. How are you going to deploy materials, especially over top of other materials? What's allowed? I already talked about low ground pressure, but you don't want to drag materials over subgrade. You don't want to drag materials over top of other materials. You get scratches and damages that often go unseen and result in issues in the future. So I'll move on to earthwork right now. One of the first things you get to on earthwork is your tie-ins. They're going to be exposed. Compacted clay liner, you're tying into an existing cell. I didn't go through the sequence and photos here. I just went with a final photograph, but you'd be benching into your clay as you build it up, and then you're going to tie in. Well, this is all going to be exposed at the beginning of the project so they can tie in and bench in. When that material is exposed, somebody should be there to mark and record damage locations so they can be found again. The material's often damaged as it's exposed, and this material gets covered up. It might get silt, it's going to get stuff running off in rains and silted over. And people will think there's no damages there when in fact damages may be there, and they're lost and nobody ever finds them again. So if you don't mark them as the material is exposed, waiting, to me is an inability to ensure all damages are located and repaired. Even if you're doing a leak location system, you can't guarantee a lot of times that you're getting over areas that may have had damage. Soil desiccation, this is another big one. It's preventable, but it's a big issue largely because people don't have a soil maintenance or protection plan when they're doing earthwork. What are you going to do during weekends to maintain moisture conditions, holidays, downtime? These things should be done. There can be a watering plan, but contractors don't want to pay their people to come in on overtime on a holiday weekend to moisture. So what are some other options? If you're not going to do that, how are you going to protect it? These things should all be addressed. Similarly, nuclear gauges, how do you confirm that the numbers that you're getting are actually representative? I've seen projects where you run into issues, and they could have been avoided if you just took time to do drive cylinder testing the moisture on a regular basis. And before the project, you can even do it on a trial area. Have the contractor do a little trial pad and test it out. Make sure you're getting the proper results, because sometimes there's chemical composition, something with a material that just isn't right. The gauge may be wrong. I've seen it. And these things are all easily avoidable and can greatly increase the efficiency of your project if they're thought out and done before the project begins or at the very inception of the project. Uh, the world of construction stakes, it seems like we're maybe getting to less and less construction stakes with GPS, but we still see them used on projects here and there in compacted clay liners. And, when it's a compacted clay liner and you're dealing with permeability issues, those stakes need to be removed. They used to be written into the specifications that they needed to be removed, each lift staggered, things like that. But you don't see that much written into the specs anymore because GPS is there. So if you're on a project where the construction stakes are there, you need to keep that in mind. So that's really the last of the things I have per se on earthwork. So I'm going to move into all the different steps of the geosynthetics here for the majority of the rest of our time together. Materials, I like to warn people of this. I've talked about it in numerous training classes, but beware of average test values. Look at the values, examine the values. A minimum required value can be misleading. You can make that minimum value, take the case of this break elongation. You have 4 of the 5 coupons tested, over 110% of the required value, but yet you have one value at 44% of the required value. The overall average is fine, but what about this low number? It's something that people need to look at. We've seen it on projects where, these low values cause problems. They can be problematic for the welding, the installer doing their welding. We've seen where these low values in thickness sometimes combined with other values lead to problems with the welding, and people are blaming the installer when really it's the material itself that's causing the problem. What's acceptable? I can't really say that. I don't have enough background or experience there, but you need to look at it. What's an acceptable standard deviation, maximum value, minimum value? I think minimum values in some of these instances may be better than the average value or an average value with a minimum value, or standard deviation, something to that regards. That's just something that, best practice is to look at this stuff and, maybe do some additional testing if you're seeing issues like that. Then when it comes to doing your physical inventory of material that's shipped to the site, be aware of rules that are missing in a sequential order. Most of the time nowadays, you're going to get production runs that are made for your site. You'd expect the rules to be chronological in order, but if you see gaps, hooray, you should commend the manufacturer. They probably caught something. But one thing a lot of people don't realize is, although they caught something, their testing is going to be at a certain portion of the roll, and that may miss if the issue propagates itself. And we've seen that on projects where the issue's gone in the first footage of a roll, but it reappears later on in that roll or the next roll outside the rolls that are missing. So just something to keep in mind there. You may want to do further examination. Might not warrant testing, but it definitely warrants, your field people keeping an eye on the material as it comes out and seeing if there's something different there. It would be helpful if the manufacturers would say why it's missing. Engineers can request that, but whether the manufacturers provide something honest or not is, I don't know. I've never seen anybody deal with it, but it's always our suggestion since having this occur on our projects. Then the material handling, as the material's being offloaded, you really want people who are familiar with the material who will handle it gently. You can see in this photograph here that, they're placing it, maybe it's on sand. I can't tell what it is, but they should have it, stacked on something to get it off the ground itself, because the sand or clay, whatever it is, if it rains, it's going to wash in there. It's going to be in the seam area. The installer is going to have to do a better job of seaming, cleaning the material, and it's something that's avoidable. Just take time to get it elevated per the manufacturer's requirements off the subgrade, and you don't have to deal with that issue. I talked about offloading and what happens when you don't have people who are qualified or experienced with geomembrane offloading it. Another thing that we recommend, especially for winter, is going to be storing indoors, especially if it's going to be long term. Long term, you can keep the material conditioned better if it's indoors, but of course that requires more handling potentially. But if you know that you're going to be storing it, it could be offloaded indoors when it arrives, like it is in this case. Inventory control. I mentioned an improved inventory list, or I think I mentioned it. I was talking about the inventory, looking at the past example of the sequential roles that are missing, but somebody should provide an approved inventory list that's used, and the technician should carry that with them. One of the procedures we use in our electronic collection is that we have the approved inventory list in there, and if it doesn't come up on the pre-populated menu, then the technicians know to take a look at it. Why is it there? Why isn't this role there? And we've got material issues that way. You should have continuous updates daily. Check the material. When you're inventorying it, spray paint is a good way that people use to make sure that they know what roles are there, what roles are approved. We always recommend spray painting, on a core, maybe on the face of the liner somewhere away from the edge of the sheet itself, but never really painting on this edge, because the paint goes in there to where they have to weld. And sometimes you'll see where the paint gets in there, the installer can't clean it. Now they have a bad seam in that area, and sometimes it carries forward. Mark and do not use on rejected rules, making sure they're clear, because inevitably they'll end up in a stockpile where people think they should be used. And that's one way of avoiding it, making sure ideally it's stockpiled separately, but people come over, try and cut it for repairs, or it's going to be a rub sheet. Everybody says, okay, you can use it as a rub sheet. Well, now the paint gets lost and it ends up being inadvertently used. So best thing is just to keep it out of there and not use it for anything. Material staging, a couple of things on this. Here's an example of a textured geomembrane sitting on the geomembrane itself. The installer has to use care when they set it down, and then again when they move it, that material is going to rotate as they lift it up, and you want to use care that it doesn't rotate and slide. This photo on the right is scratches, and these scratches are actually from GeoNet that was placed on the geomembrane. The installer, had it there for whatever the duration was, and they pick it up and it scratched the geomembrane. And now you need to repair these areas, and you can't repair each scratch. You need to repair that with a patch. Well, what's the proper way to do it? Nobody wants to cut another hole in the geomembrane, but the same thing with a scratch. If they're stress on them, they can propagate and go right under an extrusion welded patch. So you end up, maybe the best thing would be to cut them out, but now you got another hole in the geomembrane that you're covering with this inferior extrusion weld. Best way to avoid that headache of trying to figure out what the best repair is and what's the least amount of, damage to the system, quality to the system, is avoid it in the first place. Take proper care. Maybe use rub sheets if you're going to set material down on the geomembrane. Then we commonly see material being used, as ballast in the anchor trench. And they set it down and then you bring it out after a rain. This is a drainage geo composite with geotextile on both sides of a net. And each side of these, the bottom was all silted in because they were in the anchor trench. It rained, the silt washed through it, and people want to use this material, but you shouldn't. It's damaged. It's all the layers are impacted now. So the best thing you can do would be to replace it, but nobody wants to do that. It's not cost effective to do that, but you got to avoid these situations in the first place. Don't drag materials over the subgrade. I've said that before, no matter what it is. If it's on top of a geomembrane, it's especially true. On top of a compacted clay liner, whatever other soil earthen subgrade you may have, same principle. You want to get the material lift it up so it's not riding along. And you can do that. You may have to put down a rub sheet, pull it out on a rub sheet, and then slide it into place to minimize it. But these things all take time, and that's part of the reason they're not done. But we end up with inferior products because of it, because you end up with scratches underneath that nobody sees, and sometimes holes. People step on things that got dragged in there. There's a whole host of issues with dragging the materials on a subgrade. Then another one, we don't see it as often, but some of these materials still use staples. We don't see it as often. Some are getting to plastic cores, but anytime you have material with the staples in them, there's a risk of those popping off. The best thing is to control your deployment and then trim off the material. Photo on the left is a staple, and those things get moved around. They get picked up in people's boots, work shoes, blown around, dragged around. People are cleaning up supplies, dragging them. They end up causing scratches. Best thing is, avoid it. Keep those contained. Cut it off before they're exposed. If you can keep the core wrapped up and cut it off, you're usually not gaining anything on that last part of the roll anyway there. It can be done. If it's not, you really should be out there with a metal detector. Otherwise, you risk having staples cause holes in the system. Rounded clamp edges, this one by now should go without saying, but here's a clamp that's not rounded. When they round them, they grind them. They should be ground not only on the corners, as you see here, but also on the inside lip, so that when they clamp together, it's not a sharp edge on sharp edge. And this next photo coming up, this is from a marketing advertisement from an installer, and they're showing that they're not rounded, and they're showing damage right here. As a result, and that's what happens. You do get the damage. I think, this is another one of my pet peeves as in the industry, is that some of these practices, people don't care what they show on their websites anymore, or their projects. You can look around LinkedIn, you can look at websites, you see it all over the place. Some of these things that are best practices or even normal practices aren't being followed, and it ends up with people that are looking for resources taking these practices as well, it's on my website, or we've seen it on somebody's website, so we thought it was a good practice. And I think as an industry, we really need to self-police that, use better care of what we're promoting out there. Again, damage caused by, non-rounded hand clamp. Here, the operator should have caught it. It's right between the seam. They should have been cleaning. They should have seen that. They didn't notify it. I know people, I think I talked about this one in a prior webinar, but they spent, 4 to 5 hours looking for this damage. They ended up, it was 400, 500 foot seam. And so they did, the isolation, cut a hole at 250, see if they have air. Okay, they isolate it one side, leaking, the other isn't. Then they go to 125 and kept isolating it down till they had a 4 or 5 foot section to where they could find this, and they cut that section out. But now you got 2 dozen extra holes in the liner. I suggested they should just cut out the seam there and replace it instead of putting extrusion patches on, but they didn't. And so now we got an extra 2 dozen inferior welds out there that we didn't need, all because somebody had these hand clamps plus the lost time. It's a different set of hand clamps. I've not worked with these. These didn't seem to cause as much damage, but yet they're serrated on the edges. So, I don't know. I can't speak to them, but you see different things out there as people try to find solutions. Gridding seams and panels, regardless of whether you're using GPS or not, gridding is still a viable practice. You want to keep your paint or whatever marking you're using away from the seam. It shouldn't be right on the edge of the seam. That way there's room for repairs if there's something needed. But that's one way you can quickly reference damages, and you can ensure that everybody else on your team uses the same measurements. You may not use the same measurements as the installer, but from a CQA standpoint, using the same measurements, at least everything you use at one location is going to be referenced to the same measurement, and you don't have the questions, opening Pandora's box. Is that repair at that 2 foot repair at station 35 really the one that was at 30 feet by somebody else. It just is a better way of doing um, quality control anyway. Partially labeled, labeling partially used rules. This is critical. I think it's not done often enough. It used to be in all the specifications, but again, it's something that seems to have, slipped in a lot of recent specifications that we're seeing. Labeling the corners um, with a panel ID. This is especially important when you're having people that aren't familiar with a liner, like a third-party surveyor, come out there and do the as-built. In this case, the paint mark should have been placed further away from the weld so that they're not in the way if you're doing a repair. Um, but it's handy to mark these, and a lot of times, the surveyor is not going to look around to try and figure out what panel they're on. It makes it a lot easier for them. Roll tags, collecting roll tags, as a CQA, I believe, this is critical. This is something that you should be doing to help figure out, what rolls are and panels were used that day, that you're always on top of your inventory control. We found it just to be very helpful in our field experience. Trial seams, moving on to the trial seams, a lot of specifications don't really deal with your starting peel incursion. Everybody goes by the GRI GM19A, that 25% peel is allowed on your D-strips, but what peel should be allowed on your trial welds? And my argument is always that you should start for zero. You always want to start with the best weld that you can and allow the most flexibility in case something goes wrong. You don't want to start at 20% or 25% and then have all these seams failing because you started, close to your limit. Just a best practice that we've seen. And, a lot of people incorporate this one now, but people don't write it into their specs, unfortunately. As I mentioned, we're an evolving industry. We've been learning a lot, in the industry about installers overheating the geomembrane. When I first started in the industry, this photo on the right really seemed to be more common. You wouldn't have these breaks at the edge of the seam, and you'd have elongation at the edge of the seam, and it would elongate in the sheet. It wouldn't necessarily originate at the edge of the seam, it would originate in the sheet. And you start seeing more of these breaks, and they're at the edge of the weld. And what we've learned as an industry is that part of that's being caused by this overheating that's going on in the industry. And as I mentioned, I think I mentioned at the beginning, fusion welders, earlier versions of fusion welding, they couldn't even, the thermal welds, wedge welders couldn't go as high. They didn't go to the temperatures they do nowadays. And that may be part of the reason. We're still evaluating this. There was a big panel discussion at Geotechnical Frontiers earlier this year. We're trying to address, what needs to be done. How do you stop the overheating, because you're getting passing peel and shear, but you're compromising the geomembrane. Along the same principle, you want to do your trial welds on the subgrade. This is another one where you don't see it on the specifications as much as you used to. And it can be problematic. You end up in arguments, and you end up with engineers saying, hey, I can't enforce it. It's not in the specs, but somebody should have put it in there. Somebody should have put it in the CQA plan. One welding on the underlying subgrade component. In this case, it's not earthwork, it's geosynthetics. They're placing a secondary geonet between the primary and secondary geomembrane. So the geonet is actually on top of the secondary here for their trial weld, and they're welding. And then that allows you to make sure that it's, not burning through, not sticking to the geonet. You're getting the proper penetration. You have the proper settings for the materials. In this case, it's a T-bead that we're looking at, where they made a T-bead and they burn through. So we suggest that they make a T-bead on the trial welds. You don't have to test it for the peel and shear, but you can at least see if there's any over penetration. What does the penetration look like? Is the process correct? It gives you another tool to evaluate before you start making thousands of feet of weld. Trial seams as far as extrusion go, I feel, and I've been saying it for at least 10 years, if not longer, that you really should be going by your operator and your prep crew as a whole team. You find that the person doing the grinding can make or break the extrusion weld, but so does the heat tack. Beveling. Beveling should be done before the geomembrane's ever put down, but it's not done in some cases, and people are trying to do it after the fact and damaging the geomembrane. Again, each interface type for operator and machine combo, your textured, smooth, textured welds all should be evaluated as part of your trial seams. And, I give a little bit of reasoning why in this spreadsheet. This is in other webinars, so I'm not going to spend more than a minute or two here, but, you got your different footages, and your footages all add up pretty quickly. And a lot of times these are missed. If you're using a smooth, textured geomembrane with a smooth welding edge, you'll always have different interfaces, and they should all be tested. And the reason they should be tested is you'll see, smooth, you have a much lower failure rate on destructive sampling. When anytime you involve textured geomembranes, that failure rate goes up. And as an example, on this project we had here, we had 751 foot of smooth textured weld, but no destructive samples were taken on it, even though failure rates tend to be higher. And then tracking, I've talked about this one in past webinars too, but, are they being tracked properly? Everybody will track destructs chronologically in the way the seam was welded, but what happens when the operator did, 20 foot, 30 foot wide textured cross seam, and then they move to smooth. If that fails on the textured chronologically, the study we did, they always pass when they go to the smooth, but nobody's looking at the rest of the textured they did. Should be some type of protocol dealing with that. End coupons, maybe not full destructs. Nobody wants to cut destructs on every single cross seam out there, but something needs to be done and looked at. Another big thing, a lot of people don't realize is that you need to verify the load cell numbers for the calibration certs. We find this quite a bit where the certifications don't add up. On a Demtech machine, they display, at least initially while it's initializing, and you can confirm them to the sheet you have. And you need to do this on a regular basis because those things can be swapped in and out by somebody that knows what they're doing. I'm not familiar with other manufacturers, but I speculate, some are similar. So you always want to verify. Same thing with where you set up the tensiometer. There's going to be a lot of foot traffic where the tensiometer is set up because they're going to be going over there to check their trial welds. Best practice would be to perform it off of the installed geomembrane. Otherwise, they should put down a large rub sheet under the area where people are going to constantly be walking to. People tend to drop equipment, drop knives, be cutting there. Best thing would be to not do it on the geomembrane, but if it has to be done on the geomembrane, take appropriate preventative measures. Then you get to welding, different types of welds, these vertical welds, both a fusion or extrusion. If there's vertical welds, now you have gravity pulling down. You can see the effort this guy's taken here, trying to weld. He's, unfortunately, it's about as tall as him, so now he's going to have to reach up over his head. Things like that, you can do vertical trial welds. You can set it up. We've done it in the past. And sometimes the settings and procedures need to be adjusted for that vertical welding, but they're not caught. If you're doing the weld on a horizontal, you can obviously apply a lot more force, and you end up with inferior welds when it gets to vertical welding. So those type of precautions are a best practice we suggest. We always suggest cutting the coupons with dies, but dies get damaged, broken, need to be replaced, things like that. You always need to correlate the coupon back. You can't take the value on the screen because it needs to be correlated back to the proper width. And 1-inch wide coupon, if it's required, 91 pounds per inch is required for your peel test on 60 mil. Does a 99 pounds per inch at 1.1 inches wide coupon pass or fail? You got to divide it out. You'll find out that it fails. It's going to come out to about 90 pounds per inch when you divide it out. So it fails. 100, it would have been 90.9. So that's why I didn't use it. I didn't want to get into the debate about whether 90.9 rounds up to 100 or not. That's something somebody else can debate. But yeah, I'll leave it there. I'm not going to answer that one. Trial welds the crosshead speed. You feel like you shouldn't have to tell people to verify this, but it's the best practice. Any of you engineers, regulators are out there, you should be looking at these. See, are these people on your project doing this? Are they testing at the right crosshead speed? And a lot of times you'll find that they're not. Demtech gauges, it's right there on the screen, or Demtech tensiometers. I think Leicester has it as well on the screen. But there's some old machines still out there that don't have it, and you can measure it. You can mark something and measure 2 inches, measure 4 inches, calculate it back out, see what the actual crosshead speed is. If you're using the improper crosshead speed, it does impact the results. Production seaming, proper electrical setup is essential. And I've talked about that in past webinars. There's guidelines on the length of cord, gauge of cord, number of connections, for different welding machines. But this one I wanted to highlight, best practice ideally is you don't fuel on the geomembrane or in the cell, but, not fueling in the cell is just about not avoidable anymore, it seems. So, the next best practice is to make sure you have some type of containment system. Here they're on the subgrade, but you really don't want to have a spill on the subgrade either. But if it is there, at least it can be cleaned up a little bit easier and disposed of in the proper manner. But rub sheets with lips, for spill control is a better practice. End coupons, we always recommend end coupons. They're a free quality check, but they're only as valuable as your specifications. So you need to include details. Are they being tested by hand or tensiometer? Our recommendation is by tensiometer, but that ties up people. Our recommendation is that they be QA observed. Otherwise a lot of times they just get thrown away. Nobody says what happened. What's the frequency? Is it every seam? What do you do if it failed? Are the values recorded? These are all things that really should be addressed, and they can help the overall quality of your project. It shouldn't have to be said either, but a best practice is to periodically check for the proper welding rod and the resin from the manufacturer. Everybody says, HDP rod is good for, all the HD products out there. At least that's a general belief. Nobody gives a different answer, but I think because of the proprietary blends of the different materials, I think you're better off going with a resin from the manufacturer, and it should be the proper resin, HD resin for HD liner. I think that's the best practice that you can go with. Non-destructive seam testing, inspecting the gauges prior to use. Are they functional? Do they meet proper specifications and the ASTM requirements? These gauges here, if you look at them closely, looks like they're about 3 pounds per square inch per brain stuck per division, basically, graduation, per tick mark, whatever you want to call it. Well, the ASTM says that they should be 1 PSI at a maximum per the testing range. So these would not meet the specification. Another thing is, you really want to take a look. If you're a engineer, if you're, a regulator, somebody out there visiting the site, and you start seeing 30-30 on all the air tests, watch them do their air testing. There are people out there that'll do 30-30 on each test, but it's time consuming. A lot of times it might be 29, might be 28, and it's written down as 30, might be 25. We've seen it's 35 and it's written down as 30. Well, you walk by later and it's down to 30, you don't know that it started at 35. So now you think the test passed when it might have failed. It's really critical to get people properly trained. That should go without saying, but it doesn't, unfortunately. So it's always something to look at. Um, Vacuum boxing, a few things on vacuum boxing. A lot of times the vacuum test operator is going to be your lowest guy on the totem pole. They're not trained, so we suggest doing a blind leak on a scrap. Make sure that they can identify a leak. They know what to look for. Verify the gauges are working. Verify, what the specs are. Are you testing to 5 psi, or is it lower than 5 psi? Can't typically be achieved by the shop vac motor type vacuum boxes. So you need a Venturi system in a lot of cases there. So all that should be looked at, ironed out. How's the crew going to verify a leak? If 100% CQA isn't there, sometimes they don't. Our suggestion is to have 100% there, but these markings, they should be recorded immediately if you get a leak, because as you can see, things get lost. If they write it over dirt, a lot of times it'll wash away. Things get missed, leaks get missed. You think it would go without saying too, but don't apply water on the weld until it's cooled, for your vacuum testing. That's just a good practice. Otherwise, you're shocking the weld and could be causing crystallization, long-term damage to the weld. Retesting program, we found on some of the longer-term projects, you go back and retest certain amount of patches a day where you tie back into something that's close. You don't want to walk back through something that's been completed, dragging equipment all over it. Needs to be close, but we found where poor grinding has led to failures, and you got to go back and evaluate that. Holiday spark testing. A lot of specifications tend to leave this out. I'm not sure why. It used to be common years ago, but you want to have your welds tested to the best ability as possible. So you also need to get that discussed in the pre-construction meeting and what the proper operational procedures are. I really left this one in here, with the air lance as a, reminder. Regulators, engineers, technicians as well, but you need to make sure your people are doing and understand the proper procedures when you're out there inspecting. You should be able to identify as an engineer that, hey, this guy's not doing this right. I see he's not doing it right from a photo. I see it's not doing it right in the field. During my site visit, what's going on? Why is that happening? And address it. I've talked about the destruct, using an interval, not fixed location, extensively in past webinars, so I don't want to hit on it too much. We're getting close on time here, I know. But, the intervals are yellow here for those of you that haven't seen it, and some people still have us mark every 500 or 1,000 feet. You end up with samples here. They're not doing you any good. You need to use them, to identify, test suspect areas. If you don't have suspect areas, put them somewhere where there's already a hole. Test the different interfaces, and you can do all that by using it as an interval where you're looking at, the 500 foot as an interval, not a spot where every 500 feet I need to put a destruct. Put it somewhere within that 500 feet that's not going to compromise the integrity of the liner system. I've already touched on your different interfaces. I think extrusion welded patches should be included. I don't like taking destructs on extrusion repairs, such as a destruct repair. I like taking them on the smaller ones where I can get the whole repair cut out. And, it can be repaired, but you don't have all this extra welding going over, overlapping extrusion welds like you do if you put it on a destruct patch. So I think you end up with a better quality weld in that regard. It allows you to examine the sheet. Destructive sampling tracking, tracking, you need to verify that the tracking's been done. And where would this sample be? This is destruct 20B on a project we're auditing. We come out there, there's no tracking, nothing's been done. Well, if it's a before sample, do you know where to go? We don't have, if we're auditing, we don't have the paperwork in some instances, but If this is a before sample, then this sampling would have been up there towards the top of the picture would have been the original sample. And that's because, trick we learned in the industry years ago, you put your left foot on the lower sheet facing the seam, down the seam. That'll tell you which sheet was the lower, the way they welded. Um, just a little trick there, not really a best practice, but it's a trick to help you out. Repairs, you need to have proper repairs designated in your specifications. This should have never been terminated like that. They should have had a circle cut at the end and then a patch at the end, cut it out, patch where the overlap doesn't meet the specification. Prepare your areas, as I think I mentioned before, but remove all straight line cuts. They can propagate below the extrusion weld under stress. At a time, have the operator at his time of repair in case something fails. Circular patches are not what I understand to be a best practice. They should be a rectangular patch with a radius rounded. This one's improper on the right. And, this one's another one. It's a circular patch. What happens on the circular patch is that people don't apply the extrusion welders, not applying the uniform pressure because they're at an angle. So that just leads to an inferior quality weld in most instances. You can reduce that by having the rectangular patch with the rounded corners. Temporary patches, they should always be marked. They should always be pulled up because moisture will end up underneath them. Marking the repair number at the same time you mark a destruct. The important thing is to log it. Again, they should be round in the corners here, would be the best practice, round those corners so you don't have any straight line cuts that can propagate. Mark damages whenever you find them. Make sure to log them. Sometimes dust, whatever, things get buried. So you want to have them logged on your repair log so you can find them again. Discuss proper repair procedures. Limit the number of beads on extrusion repairs. You don't want to have a destruct patch that has 4 or 5 extrusion beads on it to fix leaks or overgrinds and such. That's reheating the patch. At that point, they should be cut out and redone. Every time you're putting an extrusion bead on a weld that's already there, you're overheating it and reducing the quality in that area. Whoops. Fusion weld caps over X amount of feet at Palo Verde. That's what we did. We had 10-foot limit on extrusion welds, 10-foot limit on patches. If it was longer than that, it had to be cut out and fusion welded. And that's a better practice to minimize your extrusion welding. But a lot of people don't use these practices, unfortunately. Final walkthrough, I put in there, it's a no-brainer. I mean, it seems like you'd want to catch what's out there, but a lot of people don't do it. And things get missed for that reason. You need to have foot control while you're out there. If things get completed, keep people off of it. There's nothing worse than you have a 40-acre project and you got people walking all across the geomembrane that's already been walked. At that point, you really need to rewalk it again. People damage stuff, so keep them off. Cable ties, there's a lot I could get into on cable ties, but just picked out a couple highlights. A lot of times people like to take them, so installers end up having to go out and buy them. What are you buying? Some are for indoor use only. Do they qualify? It's never specified, so I don't have a good answer on that, but you're not getting the same quality cable tie in most instances. Another thing is how you tie them, we found on some projects, if they're tied across the ribs, you're putting materials over top, these heads protrude and cause damage like here to the geomembrane. So you should tie them in the channel and they can be done successfully in the channel. Burning holes, it's a questionable practice at best. I think, there's better procedures that can be used. If you're dealing with composite, I don't think you should use burning because it results in a lot more repairs. Typically, a lot of times you don't see it either. People won't pull it back up, don't catch it, things get missed. Not a good scenario. Re-inspecting cable ties. I know I'm coming up on the hour here. I got a couple slides left here, so hang around. And yeah, cable ties, we've learned that, in the heat, they tend to open up. The heat increases the spacing. It allows the buckle to expand in the heat, and the cable ties slip out. So they should be re-inspected before things are sealed up if they've been exposed to the heat. Fusion welding, if fusion welding of the geotextile layers around, use a dedicated wedge. Because we've found that, people trying to switch back, for one, the settings get mixed up, your pressures get mixed up, settings get mixed up, so you have a hard time on the geomembrane, but sometimes those resins from the geotextile end up contaminating the wedge welder, and you end up with issues trying to weld the geomembrane. Geonet, of course, cleaning dust, dirt, seagull crap, things like that need to be done before placing geonet. Cover soils, mark contour changes. I mentioned in the past webinar, I think, GPS doesn't always consider these. If the installer or the operator wasn't given a new contour map to go with, there's a good chance they're going to hit the toe, damage the toe. So it's a good idea to put something there that marks the contour changes. And with that, that's the last thing I have in this webinar. I know that I can go on more in the future about best practices. And I think I have another webinar dedicated sometime this year to more best practices. I thank you for joining me this time. The upcoming webinar is going to be June 19th, 12:30 p.m., CQA inspection and documentation tips, part 1. It'll go a lot further than some of these best practices. So I hope you join me for that one. And yeah, it's time for question and answers. I'll check here in a moment to see if you guys have any questions, but if not, I hope to see you again in June, and I thank you for joining me today. Why can't I find the question and answer thing? Let me see here. There it is, Q&A. So I got a couple questions. What are some good questions to ask during pre-construction meeting, specifically by regulators? So this one, there's a lot of things, where to begin, really. A lot of the things I've covered there, are good to address. What are your plans for deployment? What are your plans if you have a storm coming? Things like that. How are you going to verify your temperatures? How many trial well or how many coupons are you testing in your trial welds? Different things like that. I could go into detail. If you want to email me, feel free to do so. But yeah, there's a lot of questions that you can answer, and I think as a regulator, you should be asking some of those questions to make sure these people know what they're dealing with. Cold weather, things like that. And here's another question. What is an example of something a regulator has approved that should not have been? Why shouldn't it have been approved? One of those was in the first slide that I showed with the pyramid. It was desiccation, and the soil was desiccated, and a regulator, gave their approval on it. But desiccation, their logic behind it was that an leak location survey was going to be used on the geomembrane, the covered geomembrane, not bare geomembrane, and that allowed for the compacted clay liner to have the, not need to be up to the same standards that it normally was held to. But that don't make any sense to me because the specifications had not changed. It was still in the specs that they were going to have to make a 2 or 3 foot compacted clay liner, meet the permeability requirements. And, so that argument, didn't sit well with me, but the other reason why it shouldn't have been approved is because it don't meet that permeability. When you have that type of desiccation, you don't have your 2 foot of 10 to the minus 7 centimeters per second, or 3 foot, whatever the case was in this case. I don't remember the exact project or requirement, but we talked to the regulator afterward, and they said, even if the owner, it's up to the owner. Um, to make sure that things are done correctly. But I think regulators maybe shouldn't be given advice in that case. You know, you want to work with the team, make sure everybody's on the same page, but you got to be cautious in what you say because everybody's gonna look to you as the final authority. Um, so yeah, if anybody has any more questions, feel free to email me, Glenn at cqasolutions.com. It's one N. Because yeah, there's more examples, but I don't want to take up everybody's time here. I appreciate you guys coming, tuning in, and I look forward to seeing you in June. And I thank any of you that are still there, that stuck around for these answers, for sticking around. I thank you, and I look forward to seeing you in June.